Hello, welcome to Chapter 7, Section 6. We are going to talk about the base of the natural logarithm, which is the very famous number e. In this first video, usually I do the examples from the book and I do the guided practice problems, as I'm sure you're aware of by now. But sometimes I need to actually start talking about why we do stuff and where it comes from. That's why I call this example 0, the introduction. So in this video, I'm going to give you the background of how we started to develop this idea, and then unfortunately, this is where it gets kind of hard for me. Unfortunately, my only job is to hand you off to your next teacher. So after I introduce this, since we're talking about logarithms, and now you know about properties of logarithms and how to solve equations with logarithms, that kind of stuff, we introduced the idea of something called the natural logarithm, and the base of the natural logarithm, which is this special number e. And it's your pre-calc teacher is going to take it a little bit further, and then it's really going to be important in calculus and beyond. So I don't get to get into all of that. But I will start off with kind of like developing the number, where it comes from. Okay, it all comes from making money from interest. Interest basically means, and I'm oversimplifying stuff, but if you borrow money from, let's just say, a bank, okay? I guess you could borrow money from a relative, or maybe someone who's a little bit more shady, but let's say you borrow money from a bank. The bank is going to require you to pay for using that money. And it's going to be based upon how much money you need to borrow. That's called, in this case, the principal. And also like what a competitive interest rate would be, and also how long you're going to borrow the money. So when you really get into like some financial math, you're going to learn some amazing things. Now the bank also gives you free money if you let them borrow your money. This is called a savings account. So if you put money into a savings account, they will give you interest. So every month they will give you a statement and say this is how much interest you've collected. Interest on savings accounts are usually much less than interest on loans. The difference is how the bank makes money. But and this is stuff we're going to talk about in class, and I don't know how much I'm already like 3 minutes into the video and I haven't even started doing any math yet. So this is really kind of deep. Okay, so this is the formula I'm showing on the screen right now. This is the formula for compounded interest. I'm going to spend this whole video explaining what compounded interest means. All right, so there's only two variables in this function: t, which is time, and a of t, and you can tell t is the independent variable because it's inside the parentheses, kind of like f of x, and a of t is the amount of the investment, we'll call it an investment, at that time. So if I check after like 5 years, and I can figure out how much my investment is going to be worth. Those are the only two variables. And I know you're saying, and hopefully I've been building this up throughout the whole year, I know you're saying, yeah, but you got a P here, an N, and an R. There's another N. My teacher said variables are letters that stand for numbers. In these cases, these are parameters. This capital P is called the principal, and spelled just like Dr. Tucker's job. This is how much you invest or how much you borrow. For this example, it's a one-time deal. So that means it's a set amount of money. So it's not going to change, therefore it's not variable. In a more complicated problem, and I'm going to mention it and I'm going to walk away from it. In a more complicated problem, this is the way most people do things, they continually put money, like from every paycheck, into a savings account. So you can have it set up to where, like, maybe $25 comes out of your paycheck automatically and goes into the bank. So then that becomes a much more difficult problem, so we're going to save that for later. It also is the same idea for when you start to pay off a mortgage loan for a house or a car loan, because you are removing a little bit of the money that you borrowed every time, and that becomes really, really hard. So we're not going to get to that right now. This is just going to be we're going to, like everything we else do in math, and I know it doesn't always seem this way, we're going to start easy. So this is a set amount. It will be like, maybe you're going to put like $1,000 into the bank. You know, you won the lottery and you're going to put $1,000 into the bank. That's not going to change, so it's not a variable. We're also going to deal with a fixed interest rate. That's what the R stands for. Sorry about the phone, I'm in the basement. This is a fixed interest rate. So some banks are going to charge a variable interest rate. That means where the rate changes. We're not going to do that. All right? So that means whatever you get into is going to stay the same. And the N, we're going to explore what happens when you change different values for N. That does not make it a variable. Just like when we did linear functions, we explored what happens when you change the slope. The slope is consistent in one function, but it changes when I look at a new function. So that's really, really important. The numbers are going to change from function to function, but they stay constant within a function. And I know that that's something that I've had to explain a couple times, so I know it's a little difficult. So again, just here it is. You can read it. A of t represents the total amount of the investment if you put money in a bank, or how much you're going to borrow at a time t. Usually time is measured in years. And like I said, this is how much money you're going to start off with. This has to be the interest rate. It's given as a percent, but it's going to have to be calculated like all percents. You have to calculate it in decimal form. And N is going to be the number of times the interest is going to be compounded, and that's what I'm going to spend some time talking about. So let's take a very easy example. And if there are any adults that are listening in, you're probably going to laugh because this is completely make-believe. However, it's where we start. Suppose we're going to invest $1. That makes the calculation easy. In an account that returns 100% interest. There are no banks out there that are going to return that. They would go out of business quite quickly. I just looked it up. The average interest rates for savings accounts right now is like 0.5%. Okay, so this is completely hypothetical. $1 in an account that returns 100% interest, and it's going to be compounded only once. This is actually what we call simple interest. Simple interest just means we're not going to compound it. And again, at this point, I haven't described what compounded interest means. That's what I'm spending the whole video doing. Simple interest is just kind of like, you know, you're going to borrow money from your uncle. You're going to borrow $500 so you can buy some new headphones, all right? And your uncle says, yeah, sure, no problem. I'll loan you $500, but at the end of the month, you need to give me back my $500 plus, say, 10%. So you're going to have to pay back $550. That's simple interest. You figure out what percent the interest is going to be, and then you pay that at the end of the time period. The bank that you're going to invest in, like if it's a savings account, is going to pay you back the interest, in this case, at the end of 1 year. So let's still got this going on. So how much, make sure everything's lined up, how much I have at time t is going to be the principal multiplied by 1 plus the interest rate divided by the number of times I calculate my interest to the n times t power, excuse me. I've got the hiccups. So what do we know so far? So my principal is just going to be $1. Now, step away from the reality of this situation. No one goes to a bank and says, I want to put $1 in the bank. Why are we using $1? Because it makes the math easier. We're not worried about the numbers. What we want to do is we want to look at the pattern. We want to look at what's happening here. So we're going to start off easy with $1. If it's anything different than that, if it's $5,000, then we're just going to multiply by 5,000, and we can all multiply by 5,000, right? Make that a little bit more obvious. The interest rate is 100%. And of course, that's not realistic. But how would I change it? I would do a conversion inside here, which again, it's a way of, we're going to first do it with the easy numbers, okay, and then we'll look at the patterns. How do I write that as a decimal? Well, that's just 1. You can say 1.00, but 100% is just 1. So see what I'm doing? $1, the interest rate is 1, and the time is also going to be 1. So I've got a bunch of 1s here. So this means the amount after 1 year is going to be $1 times 1 plus 1 divided by 1 to the 1 times 1 power. All right, now I do want to mention real quick, why do I do 1 plus this? You might recall from pre-algebra, actually, when you calculated percents using proportions, there were, past tense, there were a lot of problems where you had to like calculate the tax, calculate a tip, calculate a discount, and it wasn't necessarily, the next part wasn't always just tell me how much tip it was. So like if you go out and you have a $30 meal and you want to leave a 20% tip, 20% of $30 is $6. But the answer wasn't 6 because the question was how much total do you leave? So it'd be the $30 plus the $6 tip, just to keep it easy. Well, that 1 right there, and which is right there, takes care of the initial investment. Okay, it's kind of like the total plus the percent. So this is the total plus the percent. That's why I have that there. And like I said, I can answer more questions about that. I'm being mindful of the time here. All right, so let's simplify this. Inside the parentheses, I've got this. And check out what I'm doing. I'm just straight up using the formula. I wonder if I'm going to explain it. I need a better marker. So I've got 1 inside the parentheses. 1 divided by 1 is 1. So I've got 1 plus 1. In the exponent, I've got 1 times 1, which is 1. Inside the parentheses, 1 plus 1 equals 2. And 2 to the first power is 2. 1 times 2 equals 2. So what this means is that after you wait 1 year, the account that you put it in is going to have $2. So you put $1 into the account, you got 100% of the account back, of the principal back, I should say, excuse me. 100% of 1 is $1. So this really means that you invested $1 and you got $1 interest. Sorry. Okay. So let's imagine a different situation. And again, if you need to pause the video or something, go for it and then rewind it and watch it again. I'm going to keep going. Let's imagine a different situation. Okay, so same idea. Let me rewrite this. All right, I'm going to save that for just a second. Let's imagine this. Okay, so I've got $1, and I decide I'm going to put it in the world's best bank where I've got 100% interest. And I'm going to put it in the bank, I'm going to walk away. 6 months later, which is half of a year, I'm probably going to stop using months. I'll mention it, but I know as soon as I throw in 6, somebody's going to be like, what do you mean by 6? 6 months is half of a year, right? So half of a year later, all of a sudden I'm thirsty. And I'm thinking, I'd really like to buy a Baja Mountain Dew. And I can get one for $1. But I don't have $1. And then all of a sudden I realize I have $1 in the bank. Okay, so I go down to the bank and I say, I would like to withdraw my $1. Now, keep in mind, remember last time, when I waited the entire year, I made $1 interest. Added to the $1 that I put into the bank, that gave me $2 if I waited the entire year. All right, so now check this out. So I'll come back to the formula in a second. Think of it this way, right? So I have $1, and that's going to be 1 plus, and again, my rate is 100%, so that's 1. But I'm going to find half of the interest rate. So instead of like the whole 100%, since I didn't wait the entire year, I only get half of that. And of course, I'm kind of explaining a little bit here, so just stay with me. So halfway through the year, I got half the interest I would have gotten. So instead of getting the full $1, I actually get 50 cents. Okay? And I'm just going to put a 1 up here for now. Actually, I'm not even going to put an exponent for now. All right? You'll see why in just a moment, because I'm building up the formula. All right, so at 6 months, which is, MOS is months, which is half of the year, I'm going to get 1 plus 1/2, which is 1.5, times 1. I'm going to get $1.50. And that makes sense because if I'd waited the entire year, I would have gotten the whole $1. But I only waited half the year, so I got 50 cents. Okay? But then I get my common sense takes over, and I say, what am I doing? The clerk takes out $1.50 from the cash drawer and says, all right, you cleared out your account. Here's your $1 you invested plus the 50 cents interest. And I go, thank you very much. I'm going to go buy myself a Mountain Dew. And immediately I have regret. And I say, oh, you know what? That's not what I want to do. Can I just put it back? And I get some eye rolls and probably some grumbling, but I go to the world's best bank. So they're like, yeah, sure, fine, no matter what. So now check this out. Now I start over again, but this time instead of starting off with $1, I start off with $1.50. So my interest is now $1.50. Sorry, my principal, my principal is now $1.50. I'm putting more money into my savings account than I did at the beginning. Okay? So now, at the end of the year, after 6 more months, at the end of the year, I go back and I say, all right, this time for sure I'm going to take my money out. So what do? I got 1.5 times 1.5, and now I have 225. And I start thinking, wait a second. Last time, when I took the money out after a year, I only got $2. What's the only thing that I did different? Halfway through the year, I took the money out for a second, looked at it, and said, put it back. And when I put it back, I put back how much I had plus how much interest I'd made at that time. And that extra 25 cents is half of the 50 cents, which is 100% interest if I kept it in for the whole year. But it's only in the second half of the year. So this 225 is my first $1 plus the 50 cents for the first half of the year, plus the 50 cents for the second half of the year, because I still make that, plus the 25 cents for getting interest on this 50 cents, which was interest. It's called interest on your interest. And that's where the word compounded means. You're compounding your interest. Now, a moment ago I said I wasn't going to do this with the exponent. This is why. This amount right here is my $1.50. When I put it back, I take that $1.50, I multiply by that, I do this again. So I was going to write it without the exponent. This can be written like this. 1, come on, marker, times 1 plus 1/2. And this is being multiplied by that, so that's 2. And of course, I'm still going to have my t equals 1 because I did 1 year. Now, what does this mean? The n tells me how many times I calculated interest. I calculated interest twice. Once at the halfway point, 6 months, and again at the end of the next 6 months, which is the entire year. How many times did it calculate the interest? Twice. That's why I did it twice here. That's why my exponent is 2. And if I put this into the calculator, I'll even do it with the 1. 1 times, parentheses, 1 plus 1/2, close your parentheses. And I'm going to use my exponent. I can actually do to the second power, but use my exponent. To the second power, I get 2.25. And that extra 25 cents came from the fact that I got interest on the interest. Okay, so now I'm a pretty smart guy. The only thing that I changed between the first time and the second time was the fact that halfway through I looked at my money and put it back. What if I look at my money more often? So let's say we invest $1 in an account and it returns 100% interest. We'll keep those numbers easy, but this time we're going to check 4 times per year. Okay, so now watch this. This tells me that my N is going to be 4. That's how many times I'm going to check, which basically means, if you keep the story going, I put $1 in the bank. 4 times per year would be every 3 months, because there's 12 months in a year. So at the end of March, now I guess I don't have to start in January 1st, okay? But anyway, after the end of 3 months, I go back, I look at my money, I put it right back in. I wait 3 more months, I look at my money, take it out, put it back in. And I do that 2 more times for the whole year. So 4 times I took my money out and put it back in. The first time looks like this. 1 plus 1 over 4. Now think about this. If I make $1 in interest for the entire year, I should make 1/4 of that for the first 3 months, which is 25 cents. So I'm going to have 1 times 1 plus 1 divided by 4. Yep, I get back $1.25. Okay, so this right here is going to equal $1.25 after the first time. Not the whole thing, I should do this, okay? Now when I put that money back, I do it again. So now I'm going to multiply this times, and I'm going to rewrite everything. I know I can just hit, on this calculator I can just hit enter, but I'm going to put it in again so you can see it. 1 plus 1 divided by 4. And now I made interest on the dollar, so that gives me another 25 cents, so I'm up to $1.50. But where did the extra 625 come from? That's interest on the quarter. So instead of, like, you know, $1.25, $1.50, $1.75, $2, I'm making interest on each part that I put in. So now this part, the whole thing, that's going to get sloppy if I do it. So just pretend. Now I'm at $1.5625. And of course, we only go to the nearest penny. I'll say something about the nearest penny in a second. That is 3 months, 6 months. I'm halfway done with the year. And if you remember from the last time I was at $1.50. Now I've made 6 more cents. Amazing. So I'm going to take this and multiply it again by 1 plus 1 divided by 4. And after 3 more months, I almost said 3 months, after 9 months, now my account is up to $1. I need to move my hand. $1.95 and 3125. And of course, there's only 2 decimal places with money. Let me move this so you can see it a little bit. I'm worried about the screen showing up. There, that's a little bit better. Okay. We'll talk about rounding in just a second. I'm at 9 months. What do? I'm going to go 3 more months to all the way to the 12. So I'm going to do it one more time. 1 plus 1 over 4. Multiply 1 plus 1 divided by 4. And now I'm at 244. 140,625. And if I say, all right, now I would like my money back, they're going to give me $2.44. And this extra bit that I have here, that gets rounded down. And if you ever saw the movie Office Space, that rounding error is what the entire plot is about. So make sure you watch Office Space. It's really, really good. And then you'll probably understand some of the memes. Okay, but that's if I keep checking the money 4 times a year, every 3 months. What if I go back every month? Now hopefully by now, you're starting to see this, writing it this way is going to be unwieldy. But I keep multiplying the same thing over and over again. What do I use when I multiply the same thing over and over again? Okay, so this is 1 times 1 plus 1/12. The 1/12 means I'm going to check it 12 times this year, every month. All right, let's hit clear. And I'll do 1 times 1 plus 1 divided by 12. And after 1 month, my account is worth $1.08 and 1/3 of a cent. I put that back into the account and I do it again. And I check it every month. How many times do I check it? 12 times. So how many of these factors am I going to have? I'm going to have 12. So that's going to be to the 12th power. Okay, let's see how much this is going to be. I'll put it in just like this. 1 times parentheses 1 plus 1 divided by 12. Close my parentheses. And I'm going to raise it to the 12th power, which means like this one was to the 4th power. So I've got 12 of these. I'm just using it as a way of not having to write it over and over again. Check this out. That means that my account after a whole year is now worth move so I can man $2.61. I'll write the whole thing that I've got, 303529, which means that it is worth $2.61. Guys, I think that I've found the secret to infinite money. When I checked it once, I made an extra $1. When I checked it twice, not only did I make the extra $1, I went from $1 to $2, but I also made an extra 25 cents. When I checked it 4 times, I made extra money. So I went from $2.25 to $2.44. And if I checked it every month, now I'm up to $2.61. Holy cow. How many times can I go back to the bank and check, like, here, give my money, put it back, give my money, put it back, give my money, put it back, give my money, put it back. Let's say if I do that every hour. Now you're probably thinking, all right, this is going to get unwieldy. But now think about this, okay? And let's just say this is not a leap year. So I've got 365 days times 24 hours, 8760. So this is going to be $1 times 1 plus, how many times you're going to check it? 8,760 times. And I'm going, so that's the fraction of the whole year's worth of percent rate. That's harder to say than I thought it would be. That I'm going to get when I check it once. And I'm going to take that and I'm going to multiply this whole thing by this quantity over and over and over again, 8,760 times. So I got 1 times 1 plus 1 divided by 8760. Close your parentheses. Raised to the 8,760th power. That's how many times I'm going to multiply this. I've made more money. Now I've got $2.71. Of course, it's 2.718. I said I got a good bank. My bank might round it up to 272, but I don't think a lot of banks do that. They usually round it down. Customer beware, okay? So this actual number was 2.718126691. Okay. I've got a genius thought. That's if I do it every hour. What if I do it every minute? So 8760 times 60 for a minute, that's going to be 525,600 times. Good thing I'm using a calculator. 1 times 1 plus 1 divided by 525,600 raised to the 525,600 power. Make sure I didn't mess up. From where I'm standing, I've got, like, you can probably see that reflection. It's like shining on me, so I got to move it around so I can see it. All right, I think I'm okay. And I think I found the source of infinite money. Wait a second. What happened? Hang on. So $2.71 and then 8. These are almost exactly the same, except the next decimal place. This is 718,126. This is 781,279. So guess what? It did actually go up, but not by much. I wonder if that means anything. You know what? What if that's every minute. What if I check every second? I'm going to be the most annoying bank customer in the world. 525,600 times 60 seconds in a minute. Okay. 1 times 1 plus 1 divided by this number. And I'm got 3,153,000. Oops. Sorry, I got a reflection. That's why I messed up. It's 31 million. Excuse me. 31,536,000 raised. Don't mess up. To the same number. 31536,000. Okay. Still 2.718. Last time it was 2.718279. Now it's 2.718282. It went up, but not a lot. Guess what? I don't have infinite money here. I don't have infinite money. I have a cap. There's a limit to how much I'm going to be able to make doing this. And that's the idea. If I compound my interest, which means getting interest on the interest that I invest. The bank gives me money to when I put my money in a bank and I leave it there, the bank gives me money for having it there. That's interest. And then if I leave it there, the bank gives me interest on the interest. And it blows up. But it looks like there's a limit to how much I'm going to be able to make here. If I compound this infinitely, so I mean every single, like, zero of a moment, okay? And of course, infinite is a hard idea to talk about. But if I compound this infinitely, then the amount at time t, and I'm still want to talk about t, right? Is going to be 1 times 1 plus 1 over n to the n times t power. As, and this is calculus, n approaches infinity. That's how we write it. So in other words, you saw how, like, the number kept getting bigger. I used 8760, then I used, well, it's too far up there, but I eventually used like 31 million, and then say I want to do it every 10th of a second, every millionth of a second, every billionth of a second. This number would just keep getting bigger. There is a limit to this. It only goes so high. And that's where I'm going to pause this video. I know this video has gotten long. Hopefully it's been interesting. It's been fun talking about it. This is where I'm going to switch over, and we'll talk about it in class. And we can actually do this with a spreadsheet. So I will share my Google, my Google spreadsheet with this and show you how this works. But this number that we're getting close to is the 5th most important number, not ranked, it's like the fifth one that you've heard about out of the 5 most important numbers that you're ever going to know. The ones you know so far: the number 0, which is the additive inverse; the number 1, which is the multiplicative inverse, so when I add 0 I don't get anything; and opposites, 5 plus negative 5 equals 0, so that makes it important. 1 is important. When I multiply reciprocals I get 1, and when I multiply by 1 I don't get anything. You learned about pi. Pi is an irrational number. It's the circumference divided by the diameter. You've also, just in this class, you learned about I. I is the, I know, I'm not using I as a pronoun. The number I is the square root of -1. So it's the basis of what some people call the imaginary numbers, and I like to call the lateral numbers. There's the 4 that you've learned so far. The new one is an irrational number, which means it's a decimal like pi. It's a decimal that does not repeat and it does not end. It goes forever. So just like pi, we give it a letter. We give this one a letter. We give it the letter E. And it actually, I believe that we name it E after the guy who spent a lot of time developing it. His name was Euler. I know it's spelled Euler, but it's Euler. All right, we're going to talk more about that when we get back in the next video.